Alrighty, friends, let's see what we have here. Mrs. Key. And let's see, we've got free response of physics stuff. So we got particle moving along the x-axis, velocity, we're still given the velocity. We know the position of 4, 2. At t equals 4, is the particle speeding up or slowing down? So in that case, I need to know what v of 4 is. I also need to know what a of 4 is. Now, if I'm you, I would put that equation into my calculator, like y equals or whatever, and I would then just find what v of 4 is, so find y of 4, but then I would also use the calculator to find the derivative, because I don't need to do that by hand. I could, in this case, but I don't need to. Now, if you do that, you get 2.97, we'll call it 9 for that one, and then negative 1.164 for that one. And then your argument's going to be since v is greater than 0 and a is less, maybe I should say, be more specific, v of 4 is greater than 0 and a of 4 is less than 0, the particle is slowing down. So I had a dramatic pause there just for effect. Okay. Find all times when the particle changes direction. So let's set v of t equal to 0. And when you do that, you'll figure out that, again, you can use your calculator for that. I would actually put y2 as 0 and then find where they intersect. But you could also, if you wanted to, find the zeros of the function using the 0 function on your calculator. But you'll find that t is 2.707 approximately. And you can say the particle changes direction at t equals 2.707 because v of t, and you should check this, but you can look at the graph to verify this, goes positive to negative there. Because just because v of t is 0 doesn't mean the particle is going to change direction. You need to consider that the sign is changing there. Kind of like for min-max type of stuff. Find the position of the particle at t equals 0. So for this one, the position of the particle, I know v of t, so I'm going to integrate. I know v of t at 4, so I know the point 4, 2. So I'm going to integrate from 2 to 0 v of t dt. And then I'm going to add to that not 2 to 0, 4 to 0. And then I'm going to add to that 2. So I'm going to do 2 plus the integral 4 to 0 v of t dt. Now if it makes you uncomfortable to say 4 to 0, you could also say 0 to 4 as long as you subtract, because this is a backwards move. Either way, you can put that in your calculator and you should get negative 3.815. Find the total distance, okay? So for total distance, that is going to be taking the speed and integrating that. So speed is the absolute value of velocity. I like to find that under the catalog. It's the first thing there on your calculator. And again, you just put that in your calculator. A lot of calculator work on this one. 5.301, and you're done. Ooh, look at that graph. Now let's see. That is f. G is defined by that. G prime equals f. So equals G prime. Make sure that's key. That's important, so pay attention to that. Does G have relative min, max, or neither at x equals 10? G has neither a min nor a max. Because G prime, which equals f, goes negative to negative at x equals 10. I guess I should have put at x equals 10 here. So this is the derivative we're looking at, And since the derivative is a negative y value right here, and then stays negative here, that means that the original function will have neither a min nor a max. Does g have a point of inflection at x equals 4? G, let's see, so this is g prime. So the slope of g prime, or g double prime, goes positive slope and then negative slope. So g has a point of inflection at x equals 4 because g double prime, which equals f prime, changes positive to negative. Just has to change sign, but I'm being specific. And then for part C, find the absolute minimum and absolute maximum. So I need to consider the endpoints in everywhere that the derivative changes sign. So let's see. That's going to be negative 4, negative 2, 6, and 12. And g is the integral 2 to x. So the integral, maybe I'll make these a little bigger, I guess? Is that a bad idea? I'll do it over here. So the integral 2 to negative 4 of f of t dt, 2 to negative 4. So we have this triangle and this triangle cancel out. So it's just one triangle, which is 4 by 2. So that's 4 times 2 divided by 2. But that did not come out. 4 times 2 divided by 2. But we're going backwards. So 2 to negative 4, so that's negative. So that's negative 4. Negative 4. And then the integral negative 2 to 2. That's going to be 4, and that's going to be 4. So that's going to be 8, but negative. Because again, we're going backwards, even though I wrote it wrong. What a silly goose. 2 to negative 2. 2 to negative 2. There we go. So that's negative 8. And then we need to consider 2 to 6, and 2 to the 6 of f of t dt is going to be 8, because that's 4 by 4 divided by 2. And then 2 to 12, f of t dt, not x, f of t dt is going to be 8 and 8 cancel, so it's going to be that 4, but negative. So it says absolute max and absolute min. So absolute min is negative 8, and then the absolute max is 8. My justification is in showing kind of those integrals, and that's all I need to do there. For negative 4 to 12, find all intervals for which g of x is negative. So it's less than 0 is negative. So that means I must consider, I know g of x is negative from negative 4 to 2 at least, but then we're still negative until we hit 2. So we're going to go negative 4 to 2, and then 10 to 12. 10 to 12. Don't worry about brackets or parentheses, not a big deal. And my justification is kind of going back to this table here. I know the integral 2 to 2 is 0. So before 2, since we have these negative values, that means that g of x is less than 0. And then from 2 to 6, we go up 8. And then from 6 to 10, we go back down 8. So those cancel out. So then from 10 to 12, we're negative again. And now this one. Certain grocery store opens, has 50 pounds of bananas. Customers remove bananas. Ooh, I like bananas. From the display. So that's removing. So that's out. Out. F of t is measured in pounds per hour. T is the number of hours after the store opened. After the store has been open for 3 hours, they add bananas, so that's in. How many pounds of bananas are removed in the first 2 hours? So that means I want to take the rate out and integrate from 0 to 2, f of t dt. Now that's just a calculator thing, so I would put that into my calculator, like y1 or whatever, and I would push buttons. And when I get that done, I get 20.051 pounds of bananas, B-A-N-A-N-A-S, are removed in the first 2 hours. Find f prime of 7. Okay, that's again just a calculator thing. I could do it by hand, but I don't need to since this is a calculator question. F prime of 7. And when I do that on my calculator, I get negative 8.12. There's a 0 there, but you don't need to put it if you don't want to. And then using correct units, explain the meaning of f prime in the context of the problem. So f of t is the rate at which the bananas are removed. That means f prime is the rate of the rate. So that's talking about increasing, decreasing of that rate. So let's see, 7 is how many hours the store has been open. So after 7 hours, the rate at which bananas are removed is decreasing, because that's negative, decreasing by 8.12 pounds per, what are my units? Hour? Pounds per hour. Per hour, sorry, f of t is pounds per hour, so it's pounds per hour, or pounds per hour squared. There we go. That was a close one. Is the number of pounds on the display table increasing or decreasing at t equals 5? So the number of pounds of bananas is going to be the integral of in minus the integral of out. That's just kind of for me. So I need to consider f of t minus g of t is the derivative. So f of 5, I almost said 7 again, minus g of 5. Use calculator for that, and I get a negative 2.263. And then since f of 5 minus g of 5 is less than 0, that means they are disappearing faster. So the number, I should probably write the word number of bananas is decreasing at t equals 5. And last and certainly not least, how many pounds of bananas are on the display table? I'm going to do this. At t equals 8. How many pounds are at the display table? T equals 8. So I started with 50. I then add in how many are taken away. And I'm hesitating because I realize that I wrote something wrong. This right here, I wrote that backwards. I was thinking of it correctly. That should be G minus F. That should be G minus F. I think my number is still right. I did it correctly on the calculator, but wrote it wrong. So then G minus F is less than 0. Okay, so I have to take into account how many were added. So how many were added, that's a G function, but G didn't start until 3 hours in. So add in the G of T's. That was a close one. Got to pay attention. I even wrote it right there and then I forgot. And then subtract the F of T's. because f of t is how many we're taking off the display counter and table, whatever it is, and then g is how many are gaining, how many are being put back by employees. So if I do those things on my calculator again, I get 23.347. So there are 23.347 pounds of bananas at t equals 8. I don't know if that's a lot or a little. So I messed up part C there with my explanation, but I hope that my correction makes sense.